So in the last two sessions, what we have done? The first session we have seen different launches of ISRO. In the second session we have seen different kind of orbits satellites are there. In this session we are mainly focusing on different ISRO programs and missions. We are focusing most programs that is happening in the recent past. Three kind of programs we will be doing. The first one is something which is recent launches. Like in last 1-2 years which launch हुआ है उसके बारे में a broad idea, not too much in detail, but you have to have broad picture of this. Now details are the screenshot from ISRO website itself. Objective is you should have an idea of learning from the primary source itself. So I will transfer this material, or you can pause the video and read this. So that is the first part, recent launches. Second is upcoming launches. Upcoming missions or upcoming launches that is being planned in next 4-year, 3-year period, that will have a discussion on this. Third one is some other technologies, some applications of space, some not per se the launches, but some extension of some technologies or some services that is offered by ISRO. This we will cover in the third part. All these three will be covered in today's session. Let's get started. So the first one is EOS 6 mission. This was launched in 26 November 2022. I already told EOS means Earth Observation Satellite. It is 8 nano satellites and 1 major EOS satellite was launched into orbit during this. Which vehicle was used? PSLV. Where it is written? PSLV C-54 mission it was. So PSLV launch vehicle is used. OceanSat series was part of this, which was I am speaking. This was launched in November 26. In December itself, it given the data on the XYZ cyclone and algal blooms data. These images were in the news, which is captured by this OceanSat that is launched in 26 November. Okay, so what it capture? Ocean changes in color in the ocean, sea surface temperature monitor, then KU band scatterometer is also a part of it. What is this KU band in regarding to? Like these are the different other important payloads in these missions. KU band, Ka band, this is something which you often seen in the satellite communication satellites. We will have details on next slide also. So these are different kind of payloads that has been in this Astrocast. What it is? 4 number of satellites. That is a USA satellite, nano satellite that is launched as a part of this program. Now we have Thibault. What is Thibault? Demonstration technology, rapid technology demonstration satellite of Dhruv space using orbital deployer. What is the objective? Constellation of multiple satellites has to be launched into space. So that demonstration technology satellite was Thibault. Now we have Anand. What is this? It is a nano satellite with having a stabilized 3-dimensional axis stability will be imparted to it. Such a satellite is Anand. Only you have to know the most fundamental what is it for. Then there was a Indian Bhutan satellite. This is a collaboration of India and Bhutan. It is also called INS-2B. So it is an Earth observation satellite that is some kind of, it will multispectral optical imaging payload will be there. It will observe the wetlands vegetation of India-Bhutan region. So this is a collaboration of India and Bhutan. This is also launched as a part of this. Go ahead. OneWeb India 1 mission. What is OneWeb? OneWeb, Starlink, all these companies, what they are trying to do? Private internet facility, what they are trying to do is they are sending a constellation of satellites into low Earth orbits. How much satellites this Starlink have? I think Starlink is not written here. How much satellites currently Starlink have? Not 200, more than 4,000 satellites Starlink currently have. So with this capacity, what they are trying to do? They are trying to beam directly from the low Earth orbit. Internet services will be beamed into XYZ locations. What is the advantage of this? You only need a modem at your hand. You don't need so much sophisticated technologies. So to taking internet to very remote areas, this is one of the most feasible options. So OneWeb is another similar mission. So similar to Starlink, the objective is to send a constellation of satellites into low Earth orbit and beam internet services into Earth. Now what it does? It was launch vehicle was LMV-3 launch vehicle. 36 satellites of OneWeb was placed in the orbit. Dedicated commercial mission for foreign customer through NSIL. What is NSIL? Commercial arm. Basically for promotion of private sector engagement, separate organization was formed. So that is NSIL. It was coordinated through NSIL, the OneWeb One Vision. This was launched in October 23, 2022. LMV-3 launch vehicle was used. Low Earth orbit of 600 km at this angle inclination it was used. The objective is KU band, KA band. Objective is beaming the internet directly into the Earth. Details of this band we will see in the next class. Next slide. Go ahead. You only need a user terminal or modem to get the signal. No other sophisticated technologies are necessary to access the internet. That's the advantage of this. Go ahead. GSAT-24, that was also a recent launch. What is specialty of it? It was first demand-driven mission. 24 KU band communication. It is a communication satellite. All the satellites we are doing right now were EOS was an Earth observation satellite. The other one, OneWeb, was a internet beaming satellite. This is a dedicated communication satellite with 24 KU band. What is this KU band? Communication satellite means DTH is the applications, other telecommunication, all this application will be part of it. Now tell me what is KU band? KU band and KA band. The difference is these are at different frequencies at this satellite communicate with the Earth. KU band is having a frequency range of 12 to 18 gigahertz. It is mainly used for television, internet, broadband internet and all these applications. Advantage of KU band is lower the frequency, what happens? We discussed on 5G and 4G. What is the difference between 5G and 4G? 5G is having much higher frequencies. So much higher frequencies means penetration through walls and surfaces for 5G is slightly difficult compared to 4G. 4G is at lower frequency, so these walls, concrete walls are not going to impact 4G. But 5G, since it has higher frequencies, these walls and concretes can have much greater impact on 5G. Similarly, KU band is a lower frequency band, while KA band is a much higher frequency band. So all these fog, rain, atmospheric disturbances, all these much less impact the KU band compared to KA band. KA band, all these distractions will be much less. But the advantage of KA band is this can send much higher amount of data. KU band have much less disturbances, but KA band has a much higher frequency ranges. So more amount of data you can send through KA band. So it is application of here comes in high speed internet, video conferencing, data intensive communication application will come here. Normal TV broadband application will come in KU band. Okay, go ahead. Now this is like 3 major launches that happened in last year. Now we are going through the upcoming launch programs of ISRO. First major one is Aditya L1. What is Aditya L1? Aditya L1 mission. It is India's first what? Solar observatory mission. It is sent into, what is specialty of this? It is sent into Lagrangian point 1 L1 of the Sun Earth system. Whenever you are speaking of Lagrangian point, it will be in respect to 2 celestial bodies. There will be Lagrangian point with respect to Sun, Earth, Moon also. So in the Sun Earth system, the first Lagrangian point, the satellite will be sent. And where it is approximately 1.5 million kilometers away from the Earth. Advantage of, what is the advantage? What is the L1 point? Tell me what is specialty of L1 point, Lagrange 1 point? We'll see in the next slide. So this is the Aditya L1 satellite, Aditya L1 mission. Objective is to study the sun. To study the sun means what all it will study? Main objective is sun's solar flare, solar coronal mass ejection, CME, all this, how is this happening. Secondly, sun, major peculiar characteristics of sun is coronal heating. What is coronal heating? Coronal, the sun which we see as a round is, that round is called photosphere. Photosphere or the surface of the sun is having a temperature of 5000, 6000 degrees Celsius. Now if you come outside of the sun, what you expect is temperature should fall. But the outside region of the sun is called corona. And this region is having a temperature of 1 lakh degrees Celsius. That means not just small increase, but a massive increase in temperature in the outside region of the sun. This phenomenon is called coronal heating. Why exactly coronal heating is happening? That is all the objective of this Aditya L1 mission. So this is the program which we have sent. It will be rotating Earth for a while, then it will be sent into this Lagrange L1 point. Details of this point we will see in the next slide. Go ahead. So what is Lagrange 1 point exactly, or Lagrange point? What is specialty of this? If you put a small object on at this point, any of these Lagrange point, it will tend to stay there. Tend to stay there means what? If you look at this, sun is there, earth is there. Earth is not static now. Earth is itself revolving around the sun. So if you put something in the Lagrange point, as earth moves, the satellite will also come along this point. Getting? You don't need to give any other energy for this movement to happen. As earth moves here, satellites will also come with earth. So this movement will happen automatically. This kind of point is called Lagrange point. Any small object, if you put there, it will stay there. That is the advantage of it. You don't need to give so much energy to keep that satellite in that orbit for all the time. Now, why this is happening? Why this is happening? Gravitational force by two bodies. There will be sun and there will be earth. These two bodies will be not same, not balanced also. Gravitational force by sun as well as earth will be equal to the centripetal force that is required to keep the orbit in keep the satellite in this point. Getting? At all these points, the centripetal force, equivalent centripetal force will be equal to the gravitational force by earth and this body. What else you need to know? Three Lagrange points will be in the straight line, two other will be in the diametrically opposite directions. Total, a two body system will have 5 Lagrange points. Anything else? Like total Earth Sun distance at only 1% of the distance in that. This is only 1% of the distance, 1.5 million kilometer we are speaking about. Earth is there, sun is there. Total distance, if you do technically only 1% at the kilometers, this L1 point will come. Aditya L1 mission will be kept there. Okay, go ahead. Yeah, these are different. This sun is going to be studied. This I already told. Sun has different layers. Core is the innermost layer. It is having a temperature of around how much it is? 15 lakh. Around 15 lakh or something Kelvin it is having that much high temperature. Then we have a radiative zone. It is reducing convective zone. It is at there for something to in the core. Now it is need to come above this. It will take 1.5 million years of that much of years it will take a material to cross this convective layer and come above to the surface of the sun. Outer layers we have photosphere. Photosphere is what we see as the visible region of the sun, visible from the earth. We see as a round, that is photosphere. It is having a very small temperature of 4000 to 6000 degrees, 6500 degrees Celsius. Then a little bit outside we have chromosphere, that is having a temperature 4000 to 8000. Then a transition region where the temperature started increasing. It is here coronal heating is starting. At this temperature 8000 it is taking to 5 lakh degrees Celsius, around 5 lakh degrees Celsius. The 5 lakh degree Kelvin it is happening. Then in corona region it is having more than 1 lakh degree, 10 lakh, 1 million temperature, 1 million Kelvin temperature it can reach up to. So how this is reaching this much temperature, that is something which is still has to be find out. So this mission, Aditya L1 mission, all study all this phenomenon. Now we have this some phenomenon regarding sun. Everything we are not going to discuss, some important things we will discuss. What is solar quake? Like earthquake. Earthquake means waves in the earth surface. Similarly, there are at times there are waves in the sun surface. That is called solar waves, solar quakes. What else solar flare means? Solar flare, coronal ejection, coronal mass ejection, all these are very similar terms. What is the point? Ejection of plasma into the outer atmosphere. This plasma will reach all these planets, and this is causing XYZ, what we have discussed before this. What else? Some only aspect. Sunspot means what? Sunspot will appear dark or bright. It will appear dark. Now, why it is dark? What is the one reason for this? Yes, there will be a magnetic trap around these areas, so that the temperature of this area will be lower than the surface temperatures. Something is there, over temperature is 6000 degree, inner temperature maybe 5000 degree, 4000 degree Celsius. This temperature difference will make some kind of dark regions in the sun. This is called sunspots. Rest of the other phenomena, I will share the material. You can read on what exactly it is. We're not discussing too much into it. This is the solar flares which we were discussing. It will be ejected into the Earth's surface. Now, when reaching the Earth's surface, Earth has its own magnetic field. Due to this liquid core we have, there is movement of ions inside the Earth. Due to this movement, Earth have its own magnetic field. Due to this magnetic field, all these plasma ejections will be diverted into it. Now, what is one application of this? Not application, one implication of this? We will see auroras. What is auroras? These solar plasma is charged particles. When it is struck with the ions in the ionosphere of the atmosphere, then this collision will lead to colorful sky phenomenon that is called auroras. This is only observed at Scandinavian countries, very high latitude regions of the Earth. That's all. Go ahead. Now we will speak on Gaganyaan Mission. What is Gaganyaan Mission? India's first demonstrated human space mission. India has to demonstrate human space capability. 3-member crew will be taken into an orbit of 400 kilometer height for 3 days. 3-member, 400 kilometer, 3 days. That is the technical specifications right now. It may change also. If it is changed, you have to take note of it. Now, human rated, what is the speciality of when we need to have a human rated system? All the safety standards will go up. Secondly, we need to have this re-entry technology. Re-entry technology. So far all the launch vehicles, what were we doing? They were carrying the satellites and putting into orbit, their function is over. Now we need some system to bring back the system safely into the Earth itself. And how it is bringing back? US has some system where it will be landing as a flight. Here we are landing as, we'll be landing in the ocean. It will be like with a parachute like system. This XYZ will be launching, put in the ocean, then from it will be collected, members will be taken out from the module of. What else? It is sent into a low Earth orbit only. 3 days is there. These are different technologies developed for this Gaganyaan mission. Integrated airdrop test vehicle mission, pad abort test, unmanned flights, manned flights. So something like test vehicle mission, pad abort test, something like this in the statement, you should at least able to identify this is related to Gaganyaan mission. Okay. Now which rocket it is used? LMV3 will be modified into HLMV3. HLMV means human rated LMV3 vehicle. Same vehicle, but some adaptation will be done. LMV vehicle specifications, you know what kind of vehicle it is? It is similar to a GSLV vehicle. 3 stage will be there, solid, liquid and upper stage cryogenic stage will be there. All rest you can read about it. Go ahead. What is Chandrayaan 3? What happened to Chandrayaan 2? Somewhere there will be 2 parts of it. One is lander and there is the orbiter. Orbiter was functioning very well. Lander, we are supposed to soft land, but we went there and crash landed. Which all countries have done soft landing on the moon? Currently only 3 countries have soft landed: Russia, USA and China. India was about to be the 4th country, but our system failed at the last moment. Why it failed? What was the explanation given by ISRO? So what it was is software issues. This pathway was having some slightly differentiation. Due to this, all this software was a major issue, not related to something bigger hardware issue. So they may correct it in Chandrayaan 3 program. So Chandrayaan 3, what it all includes? Same all the things is there. Lander, atmospheric orbiter will be there around the moon. Then there will be a lander. Then will be a rover also. So demonstrate end-to-end capability to safe landing and roving on lunar surface. That is the objective of Chandrayaan 3. Here there are very specific names associated with payloads. These names and what is the fair objective of this, at least that much you should know about it. Here it is given. Lander system is there, rover is there, propulsion module. 3 system we will see. In lander there is radio anatomy of moon bound hypersensitive Ramba. If you see in this name, at least you should be able to identify this is related to Chandrayaan mission, and this is the objective of this. Measure the near surface plasma ion density changes in the moon. Then there is a CHAST, Chandra Surface Thermophysical Experiment. CHAST is also a lander payload. This is associated with measurements of thermal properties of the lunar surface. Then instrument for lunar seismic activity. That means something like earthquake, seismic activity, it will be sensing. Now we have laser retroflector array, LRI. It is for experiment to understand dynamics of moon system. Now rover payloads, we have laser induced breakdown spectroscopy, LIBS. Some kind of XYZ chemical composition, interferometric properties of different materials on the moon it will be doing. This system will go into the lunar surface. So the experiments done here will be like with the material it is being collected there. Alpha particle X-ray spectrometer, APXS. Elemental composition of XYZ moon's composition, it will be studying what kind of material it is there. Propulsion module, there is a shape spectropolarimetry habitable planet Earth, something like this is there. It will be doing future discoveries of smaller planets reflected in light. Exoplanet study it will be conducting. Exoplanet means? Excuse me. What is exoplanet? Tell me. If it is around the sun, we call it planet. If it is having some sun-like system and the planets orbiting around that is called exoplanets. So this will be studying basically properties related to exoplanet. So these are different kind of huge amount of payloads in Chandrayaan 3. At least you have to identify. You see some names like chest, shape or something like this. You need to identify that this payload is associated with Chandrayaan 3 mission. Okay, go ahead. Rest of the elements you can read from here. Details are provided. Which vehicle LMV3 will be used for this? Go ahead. Now this is NISAR mission. What is NISAR mission? NASA ISRO collaborative mission it is. It is a jointly developed by NASA and ISRO. What is specialty of this? It contains synthetic aperture radar technique for generating high resolution images. It is something like Earth observation satellite itself, but synthetic aperture radar technology will be used, and using this high resolution images will be taken out. Now there are 2 different frequencies, L band frequency, like we told about Ku band, Ka band. Similarly, there is L band and S band. So one band will be developed by India and one band will be developed by US, something like this arrangement is there. GSLV launch system will be used. NASA is responsible for L band, ISRO is responsible for S band part of this XYZ mission. GPS capability will be provided by US. Entire mapping of the Earth will be done in 12 days. This is expected to be launched in 2024 NISAR mission. At least what you have to remember is this is a collaborative mission between ISRO and NASA, and it is an Earth observation mission. High radar, some synthetic radar, aperture radar technology will be used, and high resolution images of Earth will be captured. Okay, go ahead. Radar range frequencies will be used to image the Earth. Communication will be using radio waves itself. All satellites will be using radio. Radar is not ultraviolet. We'll see in upcoming slides. We'll have discussion on electromagnetic waves also. So this is GAGAN system. All these are like small system. At least what you have to know is who is doing it. What is the primary objective of this? What is GAGAN system? GPS aided geo-augmented navigation system. Who developed this? ISRO and Airport Authority of India. What is the application of this? Giving like navigation facilities for airplane. There will be a number of satellites, then there will be technologies communication with the ground level. By combining all this signal, you will give exact navigation technologies for the satellite. So far we were depending on foreign countries, US system and all. So we have developed something like indigenous system for giving exact navigation system. India became 4th country to offer space-based satellite navigation services to the aviation sector. 3 other countries which all will be there, you already know. Same 3 countries are part of it, US, Russia and go ahead. That is GAGAN mission. Then we have a very interesting project, that is Project NETRA. What is it? Network of Space Object Tracking and Analysis. It is said to be space debris to exactly study details on space debris. Why space debris is becoming a major issue in recent past? There is like, we have this internet beaming satellites. 10,000s of satellites are supposed to be brought into this low Earth orbit. So low Earth orbit mein kuch bhi hai, this can create issue in the later phase. Either it can hit the satellites or it can, some other satellites launching, it can get distracted. So space debris is becoming a nuisance in the recent past. So this will be exactly to track the debris, and if there is a debris that is going to be creating some problem to the Indian satellites, this will give the information on this. Okay. Up to small as 10 centimeter it can operate, it can locate the debris up to 10 centimeter size, then up to 2000 kilometer. Right now it can capture the debris. Later it will be expanded into higher ranges also. Rest you can do. Space debris is a major issue in low Earth orbit. Why? One is huge number of satellites are being launched into low Earth orbit. Second is any satellite you have to launch, you have to pass this low Earth orbit region. Third is Earth is there, low Earth orbit is here, means area is less. Geostationary means 35,000 means the amount area where you can put the satellite is much huge comparing to low Earth orbit. So debris is a major issue in low Earth orbit. Go and learn about this Kessler syndrome. This is associated with, what is Kessler syndrome? Like if one satellite or something in the space is there, its lifetime is over. Till the lifetime, the satellite will stay as intact material. Once this lifetime is over or it subjected to some crash, this will start disintegrating into so many minute particles. 10 centimeter, 2 centimeter, screws, bolts, everything will get disintegrated. And this will become a huge number of particles in the, one satellite can become a huge, this XYZ property is called, or phenomenon is called Kessler syndrome. So I guess that is all about the very important ISRO missions. We have discussed three different kind of sections. First, we discussed the recent launches that ISRO has done. Second, upcoming important missions we have discussed. Then some other technologies ISRO has been developing. or some collaborative missions we have discussed. So in the next class, what we are going to do is we will discuss the foreign countries or global countries important missions like NASA missions, European Space Agency missions, and other space agency missions. That's all for now. Thank you so much.